your eyes and just breathe. There is nothing you need to do right now. Nothing you need to solve. Nothing you need to remember. Just breathe and listen. Tonight, I want to take you somewhere. Not far, not fast. We are going to move slowly. The way the universe moves. The way the old stars move. Slowly, quietly, with great patience. We are going to ask one question, just one, and we are going to sit with it, turn it over gently, the way you might turn a smooth stole in your hand, feeling its weight, its cool surface, its quiet history. The question is this: what if the sun turned black? Not an explosion, not a dramatic ending, not the kind of thing you see in films with fire and noise and chaos. Just a quiet dimming, a slow, gentle fading, and then a black sphere hanging silently in the sky where the sun used to be. That is our question tonight, and we have a long time to explore it, so there is no rush. Let us begin. At the beginning, the sun. You have seen it every day of your life, every single day. Since the moment you were born, it has been there, rising in the morning, moving slowly across the sky, setting in the evening, painting the horizon in colors that no artist has ever quite managed to capture. Orange, pink, deep gold, the kind of colors that make you stop and look and feel something you cannot quite name. We call it sunrise. We call it sunset. We give it names, as though it belongs to us, as though we invented it. But the sun was here long before us, long before the first human ever opened their eyes on this planet, long before the first tree, long before the first fish, long before the first single cell of life stirred in the warm, shallow water of the ancient earth. The sun is 4.5 billion years old. 4.5 billion. That number is so large, it has no meaning to the human mind. So let us make it smaller. If the entire history of the sun were compressed into a single year, January the 1st, a new star ignites in a quiet corner of the galaxy. The Earth does not exist yet. By March, the Earth has formed a ball of molten rock, slowly cooling in the dark. By July, the first signs of life appear, tiny, invisible, fragile, just chemistry, learning to copy itself. By November, the first animals appear in the oceans, still simple, still small, but moving. December the 19th, the dinosaurs appear. December the 26th, they disappear. 65 million years of their story, told in 7 days of our imaginary year. December the 31st, at 11:58 p.m., humans appear. All of recorded history, every empire, every invention, every war, every love story, every song ever written happens in the last 2 minutes of December the 31st. And through all of it, the sun simply burned, steady, patient, unconcerned. It does not know we are here. It does not care about our civilizations. It does not notice our prayers. It simply burns, because that is what it does. That is what it has always done.
Let us talk about what the sun truly is. Not the symbol, not the god, not the painting on the wall. The actual sun, the physical reality of it. The sun is a star, a perfectly ordinary star, medium-sized, middle-aged, nothing particularly special about it. In the vast catalog of the universe's stars, there are stars far larger, stars far brighter, stars so enormous that if you placed one where our sun sits, its surface would extend past Jupiter. But to us, our ordinary, unremarkable, medium-sized star is everything. At its center, the temperature is 15 million degrees Celsius. 15 million. At that temperature, hydrogen atoms are stripped of their electrons. They become bare nuclei, moving so fast, with such incredible energy, that when two of them collide, they fuse. They become helium. And in that fusion, a tiny fraction of their mass is converted into energy, pure, radiant energy. Einstein gave us the equation. E equals mc squared. The energy released equals the mass lost, multiplied by the speed of light, squared. That little equation, that elegant, simple line of symbols, describes the engine of the sun, the engine that has kept this planet warm for 4.5 billion years. The engine that makes the grass green, that makes the oceans blue, that makes the air breathable. Every second, the sun converts 600 million tons of hydrogen into helium. Every single second. And it has been doing this for 4.5 billion years. And it will continue doing this for another 5 billion years. We are perfectly placed in the middle of the sun's life. Not too early, not too late. Right in the long, calm, stable middle, the Goldilocks moment of a star's existence. Now let us talk about the light. The thing you feel on your face on a warm afternoon. The thing that makes the world visible, that makes color possible, that makes shadows. The light that reaches you right now. If the sun were shining where you are, that light began its journey 100,000 years ago. It was born at the core of the sun, a tiny packet of energy, a photon, smaller than anything you could ever see or touch. And it began to travel outward through the dense plasma of the sun's interior. But the sun is so dense, so impossibly crowded with matter, that the photon cannot travel in a straight line. It bounces, it scatters, it zigzags through the solar interior like a marble dropped into an infinite crowd. This journey from the core to the surface of the sun takes 100,000 years. 100,000 years of bouncing, scattering, slowly, slowly, working its way outward. And then it reaches the surface, and it is free. It leaps into space at the speed of light. 300,000 kilometers per second, and 8 minutes and 20 seconds later, it touches your face. That warmth you feel, the gentle invisible pressure of sunlight on skin.
And so we return to our question. What if all of that stopped? Not slowly, not over millions of years, as the sun naturally ages, but suddenly, at one particular moment, call it second zero. At second zero, the nuclear reactions at the heart of the sun simply cease. No more fusion, no more energy. The furnace goes cold, and the universe continues. The stars continue their slow turning. The galaxies continue their long drift. The great dark between things continues to expand. But here, on this small blue world, something fundamental has changed. You would not know it yet, not for 8 minutes and 20 seconds. For 8 more minutes, the world is normal. The light is still coming. The warmth is still arriving. Birds are still singing. Children are still playing. Coffee is still being made in kitchens all over the world. 8 minutes of a world that no longer exists. 8 minutes of borrowed light from a dead star. And then the last photon arrives, the last one, the final messenger. It touches the earth, and there are no more behind it. The pipeline is empty. The first thing people notice is not darkness. The sun does not simply switch off like a light bulb. The change is subtler than that, more unsettling. The light shifts by a degree so small, most people cannot name it, but they feel it. Something is wrong with the quality of the air. Something is wrong with the color of things. A woman sitting by her window with a cup of tea looks up from her book. She cannot say why, but something has caught her attention. The light coming through the glass is the same light it always is. And yet,
feels different, quieter, as though the light itself has forgotten something. She goes back to her book. A man walking his dog in a park stops. He looks up at the sky. The sun is there. He can see it. But something around it, something in the way the sky frames it, is wrong. He cannot say how. He stands there for a moment. His dog looks up at him. They both look at the sky. Then they walk on.
Within minutes, the more sensitive instruments begin to register the change. Solar observatories that watch the sun constantly, that measure its output in precise wavelengths, begin sounding alerts. At a quiet research station in the mountains of Chile, where the air is thin and cold, and the sky is always perfect, a young astronomer stares at her screen. The numbers are falling. Solar luminosity output falling. She checks her instruments, recalibrates, checks again. The numbers keep falling. She picks up her phone, her hands are very still. She is the kind of person who spent her whole life preparing for discovery, for finding something new. She never imagined it would be something like this. She dials her supervisor. He answers on the second ring. She says, "You need to see this." The news spreads. The way all impossible things spread in the modern world. Faster than understanding. Faster than context. Faster than calm. A photograph appears online taken on a phone by an ordinary person in an ordinary city. The sun, dark, not an eclipse, not a filter, not a trick of the camera. Dark, a black circle, surrounded by a thin red ring like a wound in the sky. Within minutes, 1,000,000 people have seen it. Within an hour, 100 million, the comments fill with questions, with fear, with disbelief. And then the scientists begin to speak, carefully, slowly, with the particular kind of calm that people use when they are terrified, but cannot afford to show it. They say, "We are observing something unprecedented." They say, "We are gathering data." They say, "We ask the public to remain calm." But the public is looking at the sky, and the sky is getting darker. And that is where we will rest tonight. At the beginning of the question, at the moment just before everything changes. The world does not know yet what this means. The scientists are working. The governments are meeting. The ordinary people are standing in their gardens, looking up at a sky that feels different. But for now, we let it be. We let the question float in the dark around us. We do not need to answer it tonight. The sun will rise tomorrow, as it always has, as it always will. For now, let your breathing slow. Let your body sink a little deeper into the warmth around you. You are safe. You are still. The world is quiet. And the stars carry on their slow and ancient turning, just as they always have, just as they always will.